Okay, let's see if we can connect the standard normal distribution to percentiles. Again, when you're dealing with the standard normal distribution, that means that you have a mean of 0 and a standard deviation of 1. Now, these things are still in all the same places. We have a 0. That means this is 1 standard deviation. Let me go back. This would be mu plus 1 standard deviation. So that's just 1. Mu plus 2 standard deviations would be 0 plus 2. Mu plus 3 standard deviations would be 0 plus 3. The difference with the standard normal distribution is that we are looking at z-scores. Remember, a z-score is the distance you are from 0 or from the mean. And when we look at z-scores, basically we're counting the standard deviations. So if you were 1 standard deviation away from the mean, you have a z-score of 1. If you are 2 standard deviations away from the mean, you have a z-score of 2. If you were on the left side of the mean, so mu minus 1 sigma, that minus 1 is the z-score for the standard normal distribution. So we have a z-score of -1, -2, and -3. So standard normal looks at z-scores. These count standard deviations from the mean. Now, a very long time ago, we talked about percentiles. And the percentile was a line or a value that divided the data into 2 pieces. Or chunks. So by that, if we had P33, this was the value that divided the data into the bottom 33% and the top 67%. So once we found P33, we knew that 33% of the data was below 33, or was below that value, and 67% of the data was above that value. When we look at percentile with z-scores and the normal distribution, percentile deals with area. I don't want to say it equals area, but percentile indicates the z-score that divides the area under the curve into upper and lower chunks. So, if we are looking for, I think I used P33 on one. This means I want the z-score that divides the area under the curve so that 33% of the area is below and 67% stop it, is above. So let's find it. I'm going to estimate where I think that is. I know that the average is right in the middle. So the average is going to split the area into two pieces with 50% of the area on both sides. Now, when we talk about percentiles, we generally think when we're filling the area of filling it from left to right. So I'm going to estimate where I think 33% might be. Now, I may not end up terribly accurate here, but I'm going to say 33% might be right in here somewhere. P33 tells me that the area under that shaded part is 0.33. Well, how do you know that? Here's how you know. The area under the normal curve is always 1. If we shade in the area under the curve, it will always add up to 1. We want, with P33, 33% of 1. That means I multiply 0.33 times 1. And 0.33 times 1 is just 0.33. So that is how percentile connects to the area under the normal distribution and how that connects to the standard normal distribution. What we're looking for is this little mystery z value right down here. That is a StatCrunch problem. So I'm going to slide my StatCrunch over, and I'm going to go to Stat and Calculator. I'm doing a standard normal distribution, so I'm going to choose normal. My mean is 0, standard deviation is 1. Now I can't change the x to a z. We just have to pretend it says z. And we shaded to the left of our mystery z-score. So I'm going to leave my less than or equal to. I don't know what that z-score is, so I'm going to leave that blank. And I am going to change the area or the probability to 0.33. This tells me that my little mystery z-score right here to 4 decimal places is negative 0.4399. That is my mystery z-score. And that tells me that the 33rd percentile is negative 0.4399. So 33% of the area lies to the left of that number, 67% lies to the right. If you want to do another one, we can make up another one real fast. Maybe let's do one on the opposite side. Let's do the 60th percentile. So we want to find P60. And this is a standard normal. So that tells us some things. This little statement right here. Ooh. That's not a whole lot better. Anyway, this little piece of information, standard normal distribution, tells me first the area under the curve is 1. I know that we are looking at z-scores, so we'll have z-scores on the bottom. It means I have an average of 0 and a standard deviation of 1. That means my mean goes in the middle, and my z's are 1, 2, and 3, negative 1, negative 2, negative 3. Now P60 means I want the z-score, our mystery z, that divides the area so that 60% is to the left, 40% is to the right. So I'm going to estimate where I think that might be. We already said that P50 would be at 0. So I'm going to go just to the right. And we are claiming that the area is 0.60. And we are looking for a mystery z-score. So when I plug it into StatCrunch, I'm still going to use my normal calculator. Mean and standard deviation aren't going to change. I don't know the z-score again, but I do know that the area is 0.60. So I compute, and I find out that P60 is 0.2533. So that means my mystery Z. And that's pretty close to where I estimated it to be. It was a rough estimation, and that curved shape can make the areas a little bit funny when you're estimating them. But for the most part, the picture StatCrunch came up with was really, really close to the one where I thought things were going to happen. So we're in pretty good shape. If you come up with further questions, absolutely let me know.